Good morning and welcome to the JagCorner. And my camera's really dark for some reason. There we go. Wake up, camera. I'm waking up too. So, these are my first words this morning. So my voice is probably a little tired still. Kind of had a long day and a long weekend too. Still recovering from that. And excited to do some Jag stuff today. If you haven't been to the Jag Corner before, my name is Will Thorpe. I'm a programmer and artist for BitJag, which is just the name of our little Jaguar development group here at the Jag Corner. And Jag Corner is kind of the forward-facing entity that represents more the commercial side of what we do. We talk about Jag games and we talk about Atari and other retro video game stuff, and we play games every once in a while. I usually, it's every other week we do games or programming, and this week it happens to be programming. And we've been working on something called the 240p test suite, if you're not familiar with that. I've been working on it for about 6 or 8 streams now, something like that. But what it is it's just a piece of software that's been ported to several different consoles that allows people to calibrate their specifically their CRT screens, but some of the tests can be used for LCDs as well. And it's it tests things like color, things like convergence, pixel convergence, which is really important on CRTs. There's all sorts of tests. Another important one is like lag tests. So if you're using a line doubler or some sort of capture equipment, you can actually test to see how much latency there is between controller input or just between input and what's being displayed on your screen. So anyways, it's pretty cool stuff. Today we're just going to continue programming some basic video tests, things like scrolling, some line tests, or vertical stripes, horizontal stripes, and stuff like that. So there's still some simple tests that we need to tackle. Some of the more complicated tests, like the lag tests, really just lag and latency tests. I need to go study the code for that. The other tests I'm not too worried about because they're really just displaying an image, and so I'm not too concerned with the code matching exactly what's on the GitHub with the other platforms. That can be homogenized later, I guess. I guess that's a good way to put it. I don't know. Anyways, before we do that, let's take a look at a little bit of news. I haven't gotten too many huge announcements. There is one announcement we'll be covering, but there's really not a whole lot news-wise that's happened over this last week. Before we get to that, though, don't forget JagCorner.com. We have a newsletter. Every stream I encourage everybody to sign up to that if you haven't done that already. It's just an emailing list. We send out a newsletter every month or so. I'm trying to do it at least once a month, or at most once a month. I don't want to spam your inbox with anything irrelevant. I'm going to use that to kind of treat people who are following us directly with some exclusive news, at least for a little while, some exclusive news, that kind of stuff. And maybe some other things in the future, but it's really just a way I can directly contact you if you're really interested in what we're doing. So don't be shy. Sign up to the newsletter, or just follow me here on YouTube, or on Twitter, or on Facebook. Presence is there as well. But the newsletter, I want to rely on that a little bit more for future work, to be able to contact you a bit more directly. Let's see here. Yes, there is one piece of news here. So Phobos, who's been on a roll for the last couple of years, who's released such classics as Spidey X and what was it? Not Space War 2000, Wormhole 2000, and Kings of Edom, which was really good, and his recent release of Astrite, which is shipping right now, has announced another game on top of another announcement. So there was another game he announced. I think it's called Kingdom of Shadows, which is like a Zelda-like adventure game. This one is a beat 'em up. I believe there is some audio for this. It looks like you guys are hearing that. Let me turn it down just a little bit. So, kind of in the vein of games like Golden Axe, there was a game for the Jaguar that was planned. I think it was a Conan type game that looks very similar to this, but looks like he has some pretty good stuff going on. Graphics look really good. Anyways, another beat 'em up on the Jag. I'm not a huge fan of I like beat 'em ups. They're good enough. They can feel a little bit repetitive and a bit shallow on things like narrative, especially older ones. It's more about just beating things up. I think that's why they call them a beat 'em up. One of my favorite beat 'em ups growing up was River City Ransom, and that one still kind of takes the cake for me. It has just enough RPG elements to make it interesting. You can backtrack. It feels like you're actually in a world rather than just a story, but there's also there's a thin story in that game too. It's just save the princess kind of thing. But yeah, this is looking really good. Sounds really good. I can't hear it myself. I know you guys can. But that might be. So he has some music and everything going on. And it looks like the hit detection isn't too bad. So in the past, there's been a few people, and I can't remember any specific names, but there's been a few people who have started on beat 'em ups for the Jag, but have never finished them, us included. I actually have quite a few assets built for a beat 'em up, but have never, just haven't gotten around to it, having finished more than one game so far. So I would eventually like to get to a beat 'em up. I actually do have quite a few assets built, at least for characters built up already. I have a few backgrounds done. I actually have a kind of a narrative that can be played out as well, written up, at least a first pass on something like that. So it'd be cool to actually get into that someday. But anyways, this game, up to three layers of high color parallax scrolling backgrounds, transparent shadows, and lightening effects in Cry color mode, large sprites, individual palette fades per game character. And so, and I think all that means is he can use the same sprite but shift the palette for specific character, which I'm interested in how he's doing that quickly in Cry color mode. Because Cry doesn't use a palette per se. My guess is what he's doing is, because it's 16-bit color, what he does is he sets the color that he wants to adjust the palette on to something extreme, like a very bright magenta or something, and then he can easily pick that color out with a scan and replace it. Anyways, that's just a guess, though. I don't know. Anyways, really cool to see another game coming out from Phobos. I hope it's a solid title that we can all look forward to. Other than that, there's not much in the way of news, so let's get to some coding. So the last time we worked on this was a couple weeks ago. Let's get it. I'm just gonna pull it up here in Virtual Jaguar. No, let's get it running on. Let's get it running on hardware. I was thinking I know there was some problems with running out of memory because we're just running this off of through the Jaguar's RAM right now, which we may change. We may adjust my project so I'm building a ROM each time. Let's see here. What am I doing? Make reset. We need to reset the skunk. And then we're going to clear the screen or the console, and then take a break for about 2.5 seconds as the Jaguar resets. Clean the project, and then make skunk. I think that's it. To get everything. Oh, my skunk's not plugged in. Let's do that. Let me plug that in. Welcome to my duct tape production skills. There we go. Let me make that big. Hopefully my controller's all plugged in and ready to go. Looks like my scaler is working as it should. 1 second. I'm gonna adjust colors are really oversaturated on my monitor here. I'm going to fix that here really quick. I think I just adjust this value. Somewhere around there. Okay, that feels a bit better. Okay, so since you've been gone, since we've been away from this, there's been a few things I've worked on. I haven't gone as far as I've liked to. I've actually just gone through and polished a few things. One thing I polished, and this is because I needed everything to fit into RAM a little bit better, was the convergence tests. Before this was crashing on hardware because it was unpacking, and I may go through and convert these to 8-bit sprites eventually, but right now they're all 16-bit sprites, and there's like 7 or 8 of them. Oh, it looks like it isn't working. Oh no, there we go. A is working, but B isn't working. It gets stuck on that. It's not looping around correctly. We'll take a look at that. Anyways, this is just a pixel convergence test. It's really good for CRTs. Like these individual dots, you'll see that at the center of the screen, they look more like just pure white dots, and as you go out to the edges of the CRT, you'll see the red, green, and blue separate rather than converge. That's why it's called a convergence test. And the same thing with these other screens. Anyways, that was crashing before because it was unpacking all those full screen sprites. In fact, I'm thinking about doing these all procedurally eventually, just for the fun of it, which might be a mistake because if they change the images, I don't know. We'll see. I'm not sure. Anyways, yeah, it was unpacking all of them into memory while the program was sitting in memory, and our program is over. Let's see here. It's almost over 1 megabyte now, and so it was filling up. I think all 5 or 6 of those images, it was about 900K, and once they were unpacked and put inside of memory. And this is another reason why I'm thinking about switching it over to 8-bit sprites, because that would cut that down to about 450K rather than 900. Anyways, so that's one thing I've worked on. Another thing, let's see here, drop shadow test. Oh, that crashed. Didn't like that. It's not even letting me go in. That's interesting. We'll do the scroll. Oh, something's being loaded but not unloaded properly. Here, let me just reset this to show you those. There's probably an issue with the convergence test I don't have wrapped up. I don't want to spend too much time on that today. I want to do some new things. We can go back and figure out what's going on. There we go. So there's the drop shadow test. It looks like that flickers fine on screen. But in this one, you can change the shadow from odd to even frames. And then there's a few different backgrounds. So there's that Sonic background, the pixel checkerboard, and the vertical line test background. And the reason why I wanted to show this, and I'm going to make this smaller on screen, just because that flickering I know can bother people, is somebody in the comments from a few videos ago, and let me see if I can spot that really quick. Let me see if I can find the comment. I should have had this prepared. Videos. Was it the last one? Hey, it's me. Okay, yeah, so let me go over to the browser really quick. So right here, let me try to make that bigger, maybe. Yeah, sure. Hey, it's me. I was watching at the end of the stream and enjoyed watching your coding. Anyways, so Demicode here gave me a suggestion for optimizing a couple of these screens. So the checkerboard screen and the vertical line screen, they're procedurally generated. I'm not pre-building that or pre-rendering that before the program. This is built at runtime, and he gave me a method of writing words rather than bytes to generate those screens. And so huge thank you to him, because we went from, so if I back out here and go back in, you'll see that it takes less than a second to load that, whereas before it took, I think on hardware it was a little over 2 seconds to actually render those screens. And so this was a huge change. I was able to apply this to a few other places as well. And what's cool about this, and I'll try to explain this, I'm not as familiar as I should be with assembly code, but in assembly code, you can advance a address. You can load an address into a register, and then you could advance it just by doing this plus value. And so I didn't know that you could do the same thing in C code until I saw this. And so a pointer is just an address to somewhere in memory, and this just advances the address register according to, I assume, its type. And so in this case, it's an unsigned 16-bit integer, which is just 2 bytes, which is, let's see here. Yeah, I think that you can access any point in memory with a word value, I'm pretty sure, on the Jag platform. And so we advance that and then load the pixel value. And then for each loop, we do that. We just advance it by 1, and it's way faster than memset is. And so anyways, and then this is specifically for the checkerboard. And so we have this even and odd value, which is just a black pixel versus a white pixel. And it just toggles that back and forth every other pixel. So anyways, and I also did that for the vertical line test, and I expanded his code out to invert that as well. And so you can shift which pixel is white for both the checkerboard and the vertical and horizontal line test. And so that's going to be really easy to do those screens today. We'll probably do those today. In fact, maybe we'll do those first thing. Anyways, yeah, let's jump over to that really quick. I'm going to make this small again. Let's go check that out right now. Something I do want to do is I want to make sure, I'm going to pull up the 240p test suite GitHub. I'm going to pull the code up. Just something I am trying to do is I'm trying to keep it in the same order as he has in code, just so anybody who's familiar with the other platforms is able to the micro code may not be exactly the same as the other platforms or recognizable, but the overall structure of the program is similar. So the functions and where they are in the files is similar. So we're going to be skipping the lag test. Oh, whoops, I don't want this one, not patterns. We want tests. There we go. Draw stripes. Gosh. He has all this for drawing stripes. Quite a bit of code. So if I highlight that, see if it'll let me scroll down and highlight. This is everything he's doing just to draw stripes. Let me show you what we're doing. And sorry, I am bragging a little bit here. And thank you again, Demicode, for shortening this up. And here's the thing. This is pretty platform specific. Well, not necessarily. This code is actually pretty agnostic as long as you can access. The platform allows you to access memory. Let's see here. Tests. So so this is my line function here. That's it. So it's about, what is that, 80 to 30? It's about 50 lines of code, where this one is, 294 to 160. It's about 130 lines of code. So, and his is probably even a little more dense or compacted than mine is. But anyways, so it's really cool that we were able to do that, and hopefully it holds up. I'm pretty sure it holds up pretty well. Oh, there was one more thing I wanted to show before we get started. Let me back out of here. Is the scroll test. See if it'll load. Yeah, so we have this, and I've shown this before, but now you can invert the direction. So I figured out the code for the parallax scrolling. You can do that, and then you can speed it up like that, which is really nice. And I don't know how smooth that's coming out on the stream. It actually looks a little bit choppy for some reason. Not sure why. It looks buttery smooth up on my monitor. Anyway, so there's that. And then you can pause it by hitting A, which is normal. And then we have a vertical test as well. And that can get pretty fast, pretty quick. And it's tearing pretty good. Up there at the top, and we may need to fix that sometime in the future, but it works pretty good like that. And again, you can invert the direction, pause that. Let's see, get that 240. So anyways, yeah. In fact, I'm going to keep that up on screen while we get started here. Okay, on the desk here for that. Okay, just checking my phone there really quick. Okay, we were looking at code. We were seeing what comes after really the scroll test. Oh, what we should do is we should do so we did the drop shadow, right? The flickering one. Let's do the striped drop shadow. So I think it's essentially the same test. And I can check that here really quick by by running 240, the Genesis 240p test. And sorry, you won't be able to see this. For some reason, I can't get this emulator to render properly in OBS. Yeah, I'm not sure why. Okay, yeah, so it's just the same set of tests, but instead we're using a striped sprite. Okay, yeah, we can do that here really quick. Okay, I would like to not completely duplicate my code. that would be nice. But I guess that's kind of what he's doing. He just copied and pasted his code. We really don't need to do that. Because what I could do... Sorry, I'm looking at his code here. So we have our drop shadow test. Let me see if I can find that here really quick. Yeah, so here's the drop shadow test. And it's the same exact screens and setup as... so the stripe test that we want to do is exactly the same. The only difference is instead of the buzz bomber that's bouncing around. Oh, that's something else I forgot to check. Let me check one more thing in the Mega Drive version. It seemed like you could control... Oh no, he's not using the buzz bomber here. I kind of like how it just randomly bounces around, to tell you the truth. I don't see the sense in controlling. Oh, that's interesting. Matt Smith, good morning. No worries about being late. You can always rewind it and watch it later. There wasn't a whole lot in the news today, so... I'm just sorry you won't be able to see this right now. I'm taking a look at the Mega Drive version and realize mine is not quite in sync with what they're doing. So we may make some changes. I'm not too terribly worried about it, to tell you the truth. Yeah. Because what I'm thinking here is... Oh, there is one more thing I need to check. 1 second. Is the stripe sprite test. Well, he's doing that too. Might be nice to do that. Nothing special there. Okay. Yeah, I was just seeing what the difference is. So I'm thinking about just taking the function that we're using for the drop shadow test and just passing a parameter that says you do the flashing one or do the striped one, just so we can save a little bit on space, how much code we have to write and update in the future. Excuse me. So what I'm thinking, just taking a look at this, just seeing how feasible that might be. Bug vector. Yeah, I kind of want to do that because I think it's just going to simplify how we're gonna do things. So what I'm going to do is I'm just going to add a parameter here, and test type. We'll just do that. And what this will do is we'll just pass, when you pass 0 or 1, it's going to choose either the flashing shadow test, or it's going to choose the striped shadow test. Let me find that. Just got to update the declaration in our header file. And now we can just have it, let's see here, checkerboard screen, horizontal, BuzzBomber data. So if test type is equal to 0, then we unpack the BuzzBomber for that one. And this is actually really good because we've abstracted the actual movement for that bouncing around away from the sprite itself. So this should be fairly easy to put together. And we actually want this in there too, like that. That just draws black. Yeah, so we should be good there. BuzzBomber sprite. Actually, all this needs to be put inside that. Like that. And the other thing we need to keep an eye on is this text will not be running in the stripe test because it's not having to turn a shadow on and off over and over again. This is fine. Just gonna go down through here and make sure these are just the backgrounds. Am I unloading here? I don't think I am. Display. Okay, so this is our, has to do with our drop shadow text, the text that for the odd and even sprites. And so test type if it's equal to 0. We'll only run that if it's equal to 0. In fact, I'm just going to wrap this whole thing because it's an if-else statement. If test type is equal to 0, and it will do this one, our counting frames as well, like that. Hopefully this doesn't break anything. I don't think it will. So this one as well, and test type is equal to 0. This just cycles through the backgrounds. Let's see here. This is the BuzzBomber moving around. I can move him. In fact, I can move all of this up to that other if statement. I think we should be fine doing that. I don't think the order of the code is too critical here for what we're doing. Okay. So that may be all we need to do. Option exits A and B just go back and forth through the background. Oh, no, we got that. Yeah, that's fine. B just cycles through. Yeah, this will be a little bit different than the Mega Drive version, but I think it will be acceptable. Yeah, we should be good there. Okay, let's test that really quick, and I'm just going to use Virtual Jaguar to test this. Oh, we need to make sure we're passing, too few arguments. Main C at 540, go 540. And we're going to just pass it A0. Error, undeclared first use in this function. So there's still some stuff with the text that we bring up. 262. Whoops, go 262. There we go. Drop shadow. Oh, the reason why it's doing that, in fact, I need to check our unloading here as well. Yeah, this is a problem too. I need to go through and double check this stuff too. Okay, so these will only be unloaded if our test type is equal to 0, like that. Like that. And for the stripe test, we'll just be doing a test type equals 1. We'll be affecting the stripe test. So that should be fine. And the reason why we're getting that error is because by moving these two inside of an if statement, it's not visible to the rest of this section of the program, to the while loop essentially. And so all we need to do is pull these out and set them to null. And it's okay that these get run even if we're doing the other test, so the stripe test, because they are set to null. So they aren't gonna mess with anything in memory. Like that, and then we can drop these like that. We should be good. Video test, drop shadow test. So everything should just function as expected. We drop out, go in, drop out, go in. I like doing this a few times to see if the program crashes, and it doesn't look like it is, so we should be fine. Okay, so that's good. Something we need to do is prep our graphic for, well, let's just go, no, I'm gonna have to open this up. So let me do that. Open it up in a graphics editor really quick. Let's see here, stripe. It's not there. Striped. STR. There it is. Open this up in the GIMP. See if I can get that pulled up for you guys to look at really quick. I don't think I have it set up, so let me do that. GIMP. Where are you, GIMP? There you are. Okay. So the issue we have here is the Jaguar uses pure black for transparency. So we do need to open up, just to keep things consistent, I'm going to open up, where's the Buzz Bomber? I'm going to open him up because we have a certain black value assigned to him. In fact, what we're going to do, open up in GIMP. So there's our Buzz Bomber. So you'll see that his black outline is just a little bit brighter than the actual black here. And that's what we want. So I'm going to color pick that. It's going to give us the value that is, so 3.9 it looks like. And we're going to select, you guys can't see this because I'm just capturing the window, but I'm going to select alpha to selection and paint those pixels really quick. And then we're going to create a new layer, Shift B for our bucket tool, and just fill that and then drag it down. You'll see that that's there. It's very faint, so if your contrast is terrible on your monitor, you won't see this, but the stripes are just slightly brighter than the black background. And I'm actually going to, let's see here, did I? Nope, I just did a 16-bit. I'm going to, yeah, we're going to just leave this as a 16-bit sprite. I'm not too worried about it. I'm actually going to move it over here, export like that. I'm going to delete it from the 8-bit. I thought I was going to do that 8-bit, and ideally you would want this to be 8-bit, but I am not going to worry about that right now. Okay, got that. So now we can, come on, why isn't it switching over? That's weird. Weird, let me manually switch that over. There we go. Let's do the image conversion really quick. So if I go to my graphics folder and let's hear test suite graphics and GFX 16. Whoops, there we go. List it, and we're looking for striped, which is right at the end, so Jag, and then we can run the removers image converter, and we just need to tell it it's RGB, which just means it's going to be just a 16-bit sprite, and we need a binary. We don't want it to dither anything, and I'm just going to put overwrite in case we need to convert it again, and then straight.png. There it is. And I believe that's 32 by 32 pixels, if I remember right, just for future reference. We're going to pack this, striped, and our new file is actually, let me show you. So if you look down here, we have a striped RGB now. That's what the Jag image converter did. So now we can pack that with LZ77, striped RGB. And we need to give it an output, which is just the same name, but with .lz77 at the end. And that really packed. So if we, let's see here, go for sizes, you can see we started out with our PNG, which was about 4K. We went to a 16-bit RGB image, which was exactly 2K in this case, which is, no, that makes sense. And then when we packed it, it went down to 26 kilobytes. Or bytes. Sorry, not kilobytes. This is 2K. This is 2,000 bytes, and then now it's 326 bytes, so it's pretty darn small. Anyways, let's get that pulled into our program by adding it to our macro. Just right here. Am I doing, where is that other drop shadow test? Let's just add it here. And and it's called striped.lz77, and then we'll give it a name that we can reference elsewhere in our program, like that. And then we just reference it, and I'm actually going to just do it up here with everything else. Extern, just to keep all the shadow stuff together. Phrase, striped data. So what I did here is this is an external reference to that name, that macro, or not the macro itself. The macro sets up the assembler for all that. And so this is what it's going to be called, an assembler. And we're just bringing it in so we can do stuff with it in C there. And then we create a pointer of type phrase. All phrase means is it's 64 bytes long. It's looking for 64 block of memory that is aligned to 64 bytes. That's all that is. It's just in type. It's just like an integer or a byte. It's just big. That's the only difference. But this is where we're going to be unpacking the data to, and then we need a sprite structure. And the sprite structure is just a set of integers and other pointers that point to the data and just represents our sprite. So striped sprite, like that. And we're declaring it here just so we don't have to worry about scope inside of our test C file. That's really the only reason we're doing that. But now we will create another part of this if statement for loading the stripe test. So test type equals if it equals 1. So if we pass a 1 to this function, it'll load the stripe shadow as opposed to the flicker shadow. And then we just need to allocate memory that we're going to be extracting our data to, equals malloc size of a unsigned uint of an unsigned 8-bit integer times, and this is a 16-bit image, so we need to do 32 times 32, that's its width and height, times 2, because this is, I could technically just do uint 16, but I like doing it this way because I work with 8-bit sprites so much, and so this is just what I'm used to. So an 8-bit sprite is just 1 byte per pixel, and a 16-bit is just twice that, and so we take that same width and height and we just times it by 2. Really simple. Very simple to wrap your head around, at least for me, because I've been doing it a while, so maybe it isn't so easy. But now we're going to unpack that data, and we just pass the address that, in this case, it's the name that's in the assembler that points it to the address where it is in the program, and then we cast it. We need to cast this as an 8-bit pointer to our phrase pointer, which is striped data, which we just allotted memory for here. But yeah, so that should be good. That's unpacked. And now we got to do something with that packed data, and what we do with that is we just build a sprite with that. Striped sprite equals new sprite, and this is a removers library function. This new sprite, we give it its width and height and where we want it on screen. I'm just going to put it at pixel 32, and then we give it its depth, its bit depth, which in this case it's a 16-bit per pixel image, and then the address of that data, which is just striped data, the pointer to that. There's that. And then we want to attach that sprite to the display at a given layer. So we give it the sprite. So striped sprite to the display. And I have this stored inside of a structure as well. And the layer. And it looks like we're just putting the buzz bomber at the highest layer at 15. So let's do that, 15. There it is. That should be all we need to do there, because we're not doing any of this other fancy stuff for this test. So it's on screen, and we can actually check that right now simply by, in fact, well, let's go ahead and add the new test, which is striped sprite test. But in this case, we're just passing 1. Let's cd dot dot. Let me navigate back to the root of my project. Run make really quick, and it looks like it's going to build just fine. Everything should be saved. Yep, everything's saved. And there it is. It's not moving or anything because we haven't told it to do that yet. Yeah, but it is there. Okay, so the movement code I did pack in with the first test, so we may pull that back out here and see if we can abstract that away, because the Buzz Bomber happens to be the same size as this shadow, this stripe shadow. I just need to see where that's being updated. So it's being updated here. So what I can do is actually move this. I'm going to call this sprite collision, just so it's a little more agnostic. And pull it outside. And this is just going to run all the time. Oh, wait. Let's see here. Oh, I am actually... That's okay. We can abstract this. So right now I am referencing that Buzz Bomber sprite directly here. Excuse me. Let's see here. XY. Why am I doing that? Plus 13. Oh, that's the shadow. Okay, yeah. Bug vector. So I'm going to create just a new array up here for an XY position. So we have our bug vector, right? I'm actually going to change this to just vector. Vector. Let's go update those really quick. Bug vector, like that. Update there, update there. There. We're just making this more agnostic so it can work for either the flashing shadow test or the stripe shadow test. And then we're going to add another array, and we're going to call this position. And this will be an XY. That's why we're doing 2 values in this array. And the first value will be X, and the second value will be Y. In this case, we're going to start everything off at 32 pixels. And now we can make this down here, if I can find it. Where are you? Right here, we can make this agnostic. So position 0 is for the X. We're going to replace all those. I think it's just those 2. And then for the Y, it's just value, the second value in the array. In this case, value 1. Because in programming, we count from 0 typically. Okay, that should be good. And then we just have to make sure let's see here. We need to duplicate this. This will be position 0. And then, or 1 like that. Then we'll update, and we're actually going to move this outside. First two lines in this block, we're going to move this out so it's always updating. So right, sprite movement and collision. We're going to paste those right there. So updates the vector and then checks for collision. Yeah, should be good. It's a very simple collision, and for our purposes, it works fine. So there is one more thing we need to abstract here, and that's bug speed. So we're just going to call this speed. Or sorry, we're not abstracting, we're making it agnostic. So here, and then I'm going to do just bug speed. And it looks like that's all of our references for that. So there were only 3 references, and that's good. That is good. Okay, so we have that moving. Let's just make sure the buzz bomber is working and that we don't have any syntax errors. So if we go video test, drop shadow, and yep, we did mess up on something. Why didn't it like that? Oh, just need to set that like that. That should be it. Yeah, there we go. It should just bounce. Yay, good. Okay, got that. Test type, and so we now need to make a case. This could be a switch case if we wanted to do it, but I'm just using if statements for this for now. Test type equals 1. We need to now do this for the stripe sprite because right now it isn't moving the stripe sprite. So if we go striped sprite x equals position x, which is the first value in our position array, and then we do the same thing for y. That may be all we need to do because we aren't doing any flashing shadow stuff or anything fancy there. So this may be all we do for the stripe test to get it working. And there it is. I think all we need to do now is properly unload our sprite so the program doesn't crash. We should be good to go. And what's cool about this is I didn't have to copy all the code for switching the background or even the movement. We're only using one instance of it, which is nice. This is really cool. So let's properly unload this. If test type is equal to 1, we want to striped sprite, set it to so it's invisible, and then we can detach it from display, striped sprite, and then we can free the sprite structure for striped sprite, and then we can free the data that we unpacked for that sprite. There we go. Should be all we need to do. Something I am going to do, well, do we need to do it? Am I doing it up here with anything else? We are doing it for the text box. We are doing it for the backgrounds, but I don't think we're doing it for the buzz bomber. So I'm not going to worry about that. I think we'll be fine. So now if we do our drop shadow test for our flashing drop shadow, we have that. We can exit out, go into our stripe test, and there's that one. Anyways, there we go. That one's done. I don't think we need to put any more work into that. I think we're good to go. So what's our next one? Let's go to our main.c. Passive lag, we're not doing that. Reflex timing, we're not doing that. No, we're not doing that right now. Vertical scroll test. What is that one? Let's go take a look, see if that's even in our menu. Scroll test, grid scroll test. So let me pull up the Sega Genesis version again, take a look at that. Grid scroll test. So it looks like it's the grid scrolling vertically or horizontally. And it can be paused. Oh, this is going to be a little bit tricky actually, because right now I'm procedurally generating this. Actually, it's not going to be as hard as I think it will be. We're going to take a shortcut on it. Yeah, and we need to be able to pause it. Okay. I wonder why it's called V-scroll test. That's interesting. Let's go look at his code really quick and see what he's doing. I'm just curious. Let's see here. There's the drop shadow test. Stripe sprite test. There's this reflex timing. Position. Horizontal scroll test. We've done that one already. Vertical scroll test. Button, joypad. Exit, speed. Oh, can we control the speed? Let me check that really quick in the Mega Drive version. I did not check that. Grid scroll test. Okay, so he can switch the direction and he can adjust the speed. So it's very similar to our other test. I'm just curious why he's calling it vertical scroll when it's just a grid. Well, I guess it's called grid scroll in the menu, but he left it as V scroll test in code. So it was probably something different before it reached its current iteration. But we are doing similar things to the horizontal scroll test. So let's go ahead and get a start on that. And we can definitely get a start on this. So this will be the name of our function right here. Let me come back over to coding. This will be the name of our function. And it's just going to be a void function called vScrollTest. And we're going to need a couple things for this. Actually, just two things. We will need, let me think about this. Yeah, we'll need two, no, we'll only need one screen. We'll need two sprites though. So one screen, we're going to call this grid screen, like that, and two sprites. So sprite, and because they're the same, we're going to just do an array of them. Two of them, and I think that's all we're going to need for this. So I'm going to copy this, bring it in, we've declared it, and now we're going to define the test down here. Okay, kind of want to just copy and paste our previous horizontal scroll stuff. In fact, let's go ahead and do that. And what we'll do is we'll just kind of go through it line by line and see what we need to keep and see what we can take out and adapt it for this grid scrolling. So we'll copy that and we'll go up to the top. Just start there. We will need our our exit, our vertical variable. This just controls whether we're showing a horizontal or vertical test. That will be a little bit different because in the other, our scroller, which you can see there on the left, we're switching backgrounds, where this one we aren't doing that. We're keeping the grid up there, and all we're doing is changing whether it's horizontal or vertical, but we will still need this state, so we're fine. Type. I do not know what this type is. It looks like that's a variable we're not using anywhere, so we can get rid of that. Display X position. So this was used to control the position of the grid. Or the background sprites. And so we had three background sprites. Sorry, I was just thinking through how I did this. There's the three this is specifically for the Sonic background, the three there, and then the 3 background sprites and the 2 foreground sprites, and then for the vertical scroll, we just have 2 sprites, the 2 sprites, so it can loop continuously in either direction. So we'll come. Well, I kind of want to. Update this right now. We aren't going to need both X, Y. We're going to make it a little more abstract and just make it display position like that. And this will just set. Oh, let's see here. Actually, this is a little more tricky because we're dealing with PAL as well. What I'm going to do, I think we're going to make this a 320 by 320 sprite. 320 by 320. So it's perfectly square, and it's larger, it's taller than our PAL. And that way it will always loop, no matter what resolution we're dealing with. X and Y, I'm not sure what those are for yet. We do want speed and acceleration. So this is basically our vector. Pause, do want that. Key position. Oh, that's for the, I actually don't know exactly. It's for the vertical scroller, that kind of stone background scroller. In the other test, I think we can get rid of this. I don't think we're going to need it. It's really specific. We do need the load graphics. The frame and frame delay. Are we even using those anymore? Oh, we are. Vertical is 0. Animate background. Oh, that was just for animating the background. And we're not animating anything this time. So I'm actually going to delete that and get rid of these. We don't need those. Okay. So we don't need any of this because we're using different graphics, but we are doing so our screen, which is grid screen, we're going to go equal null. We're just going to set these to nulls just to follow what past Will was doing, what past me was doing. Sprite, and we're going to set our first one to null and our second one to null like that. That should be good. Okay, load graphics. We're fine with that. We're just hiding the display while we load things, and we just need if yes, if grid screen, and we'll just look at the first one for this. Doesn't actually, we'll look at the second one. Doesn't equal null, and vertical does not equal. Actually, no, we do not. We do not need. In fact, we may not need all of this. We may just need to set this up. Let's see here. That's the unloading sprites, load graphics. Okay, it's all of that. I think we're not going to need the restore palette for this one because it's just a black and white image. Let's see here, vertical. Yeah, I think all we need to do is a check to make sure it's loaded. So really, that's when it first loads. And so we just do a check. If it does not, if it's equal to null, then we load it. This is where we're going to, oh, I guess this is technically where I'm detaching. We're going to be rewriting most of this. Load graphics. And I'm actually just going to get rid of all of this. And we don't need you. Horizontal scroll. It's actually right here where we should be doing it. That's okay. We aren't going to need this either. Yeah, in fact, we can just get rid of all this because now we're this is where we're going to load, and then we're going to unload right here. Yes. Yeah, that's correct. Okay, so for our first screen, or for our grid screen, we need to allocate the structure first with this new screen function, which is a removers library function. And then we need to tell it what type of screen to be. And we can do that pretty easily now because I have a function called draw. Oh no, we do not have a function that draws the grid. Oh, should we learn to draw a grid? Should we make a function that draws a grid? Oh, excuse me. I didn't just wake up. Clean that up. We don't need that anymore. So we have, right now we do have a function, draw every other line. What I'm going to do is I'm just going to copy this every other line function. And we're going to call it draw grid. Draw grid, like so. Not worried about inverting it, so we can get rid of that, and it's not going to have any orientation. It's just going to be the screen. And we need to clean this up. Horizontal lines. Okay, let's think about this. So we want to draw, let's say our grid, our black boxes are about 8 pixels wide a piece. We just need to tell it to draw every time. Oh, we can be really clever with this too, I think. Let's see here. Kind of want to just start over on this and figure it out. This one we will be drawing a bit slower. I think we're going to have to draw this at the byte level. No, we technically don't have to draw this at the byte level. We can still use our 16-bit thing here. I'm just wondering if it might be faster to just draw the square. Yeah, let's do that. I'm going to show you another way we can do this. So right now we're doing some clever maths to draw our lines. There is another way we can do it here that is fairly fast. What we can do is we can create a buffer that represents our white square. And we draw that, we procedurally generate that, and then we can use the remover library functions to basically stamp that 8x8 sprite across a 320x320 sprite, which should be fairly quick. So we're going to create another screen here called grid box screen. And essentially we're just going to draw a single 8x8 sprite that we will use to create the rest of our grid. Let me think about that. Yeah. I just got to be clever about how I draw this so we don't have a double white pixel and stuff like that. I think what we're going to do, yeah, I'm going to set that to null as well. So we're going to be bringing in two screens. We're going to be bringing in our grid box screen. I'm just going to call it I'm just going to call it our box screen, and then our grid screen. I don't like how this is sharing a name with a pointer I already have declared. I'm just thinking if there might be screen grid. We'll just do that because this is going to be a fairly small function. Okay, we don't need any of this anymore. That can all go away. Oh, we do need... Nah. We're not going to do that. We're not going to do this trick. It isn't going to take very long to draw this. Okay. So, well, first thing we need to do is draw our sprite, which is this. Ooh, do I want to do... Yeah, let's do it in here. That's fine. Yeah, this is fine. We need to draw our box. So because we don't want lines overlapping, there's two ways we can do this. Just, let's see here. If we have a 16 by 16, what I'm going to do is I'm going to make the top row blank, and we're just going to draw white on the well, let's do it on the top line. The very first line will be white, and then the last set of pixels will be white. So draw first row of pixels. This will be an 8-bit sprite, and so it'll be 1 byte per pixel. So for I equals 0, and as long as I doesn't equal 8, I plus, and I do have a typo there. Okay, that's gone. And all we do is a mem set, and our destination is an 8-bit pointer of our box. We're pointing to the buffer for our box sprite plus I, and we're plus I, so we're going to hit every pixel there, and we're going to paint our source, which will just be our ID, which is that, and we're going to just paint one of those. Yep, that should do it. And then we need to paint the last column of that buffer, which is a bit more difficult math-wise. The way we do that, because this is an 8 by 8 pixel, actually no, this is going to be pretty simple. It will be I times 8. This gives us the row we're looking at, plus 7, which takes us to our 8th pixel, because we count from 0, right? So 7 is our 8th pixel. This should do the trick. And this is a little inefficient because we are redrawing the top right pixel twice, but that's fine. Draw. Oh, I'm dumb. There is a way easier way to do this. We're just going to go draw white pixels. So in the removers library, he has some functions for drawing lines. I was doing this the hard way. So let's go ahead and open up. I'm going to open up the source code for those functions because we did use them a little bit for something. Oh, for our screensavers, which eventually we do need to get back into this I do want to make sure that those are included in this version. So let me open up the source file for that really quick in the removers library, include, and I believe it's under the render.h header. No, it's not. Open. Is it FB2D? Line. Rotation. Nope, it's not there either. File open. Here, Blit? Is it under Blit? Nope. I've forgotten where it is. It's not under collision, console, not under display, op, render, screen, skunk. Huh. I have forgotten where that is. Is it under screen? Screen, sprite, clear screen, put pixel. Okay, here they are. Put pixels. I can draw an individual pixel to the buffer if I want to. That is awesome. Or we can draw horizontal and vertical lines. But I'm actually, yeah, let's go ahead and do this. So xmin, so draw a horizontal line onto the screen from point xmin y. So that's the row. So it's the first pixel and then the row to xmax y. Interesting. Yeah, let's give it a try. I've never done this function before, so we'll see if it works. So we'll draw a horizontal line, and it wants the xmin, which will be just the first pixel, and it wants the row, which is our first row, which is 0, and it wants the max, which is, I assume 7, because it's going to be, no, we want 8, because it's going to be running through a loop, I assume. Hey, that's a lot less code, isn't it? Now let's do vline, which I assume is using the same syntax as our hline, so we want to give it our minimum, which is the first pixel on the column, and then which column we're doing the 8th column. That may be 7. Let's do 7 just to be safe, and then we'll be able to tell if that's wrong later on once we start painting this buffer to the other buffer. And it's going to be doing 8 pixels. So, okay. Draw white pixels. Oh, we need to give it a buffer. Forgot to do that. The buffer goes at the very beginning, which makes sense. So this is going to be box, just like that. And I'm going to run a clear screen on this, just so it cleans it up. Before we draw that. Okay, and I'm going to run a clear screen on our grid screen. On grid, like that. And now we can copy to, what we're going to do is we're going to copy this buffer, the box buffer, onto the grid buffer across the whole thing. And basically, like the stamp tool in Photoshop, we're just stamping that over and over again until it's filled up. And so let's write some code to actually do that. First, we need to tell it where inside of the box screen it's going to be drawing from. So we have to tell it where it's going to stamp from, and then where it's going to stamp to. And so box x equals 0. We're just gonna, the source for our stamp will start at the 0 pixel, and later we'll tell it we want to stamp from that point 8 pixels over and 8 pixels down. So it creates a box that we're creating for the stamp. It takes that, copies it, and pastes it. So the x and then the y, like that. And then we're going to go into a for loop here. Draw grid. In fact, we're going to make this a little bit more malleable. Int grid tile width. No. Width. Pixel width. Pixel width. Grid. Pixel height. And we're going to add a few more in here, int. And I'm just going to do tile width. Yeah, tile width and int tile height. Like that. So we're going to be passing in some values here. And the tile width and tile height. So basically I'm making this malleable so we can do different types of grids and stuff. It's not necessary here, but it's good practice. I guess that's why I'm doing it. So we can do tile width here on the horizontal. And whoops, this should be 7. This should actually be tile width -1. And this is tile width or tile height -1. And tile height. Just like that. Yeah, that should be fine. Okay, so now we need to run a double for loop. We'll be running a for loop for the y-axis and then one for the x-axis for copying and pasting or stamping our sprite across the larger buffer. So for I equals 0, and as long as I doesn't equal, and we need to get the pixel width and height. We need to get the tile height. We need to divide the pixel width of the total grid that we're doing by the tile width and height to figure out how many tiles we're going to be painting across and down for that larger buffer. And so we're going to create 2 more variables here called grid tile width. And that just equals grid pixel width divided by the tile width. And this will also make sure we don't paint outside of that buffer, which would cause a crash. And then our height I'm spelling that wrong. There we go. Grid pixel height and our tile height. And I'm running that once so we don't run it over and over again inside of our for loop. So we're going to do our height. As long as it doesn't equal the tile height, I plus plus. Excuse me. And then for I equals 0, and as long as I doesn't equal grid tile width, I plus plus. So this is simple. It will go to our first row here, and then it will paint each column, and then once it paints each column in that row, it will advance to the next row and do the same thing over and over again until we fill it up. Okay. So we set where we're painting from inside the box buffer. Now we need to tell it where to paint inside the grid buffer, so our larger grid. So if we go grid X, we'll start out at the height. Let's see here. Let me think. The X. No, this is just grid tile. Nope. It is tile width times I. That will go over. So in this case, it will be 8 pixels times I. So every 8 pixels will be our X. That one's easy. And then our grid Y equals tile width times, or tile height times I. Times, oh, wait. See, I've already messed up. This needs to be II, and this needs to be II, and then this needs to just be, in fact, we can just set this once, so we don't have to run this more than once. Out here, times by I. And then this one just, it'll need to reset every time we go across the x-axis or the horizontal axis. It'll do that. And this will do it every time we go across the vertical axis, but we only need to do that once per row. So, yeah. There's all that. And now that we have that, we just need, I'm going to compress all this because it's pretty readable as it is. Now we just need to paint it, and if we go back to our FB2D, we can find actually our screen. It's in here as well. I think he has it doubled up. Let me see if I can find it here really quick. Screen copy straight right there. And so we're just copying from a source to a destination according with the width and height of our tile in a specific mode. So source to destination, I gotta remember that. So our source is the box buffer, because that's the stamp that we're using, and then our destination is the piece of paper that we're stamping to, or in this case the grid screen buffer. And we are doing that according to the tile width and height, which in this case will be 8 by 8, but this is malleable now. We could do it select widths and as many heights as we want. The widths we're a little bit limited on. It has to be divisible by 8. Yeah, it has to be divisible by 8. Whereas the height is arbitrary pixel size, so you can do whatever height you want. And that has to do with that phrase alignment I was talking about earlier in the video. Sprites are aligned by phrases, not by bytes. And so you have to just make sure everything is divisible by 8, basically. And then the type. And I can't remember the type, so if we go to screen here, it should list all the types that we have. We have all, or modes, and there's all sorts of different modes, but there's only really 2 you need to be worried about for just a simple copy and paste operation. It's mode source, not destination. So this just overwrites everything. So we're stamping on a piece of paper, right? This will overwrite anything on the paper, and it will just copy from the source. There is one more. Let's see if I can find it here really quick. Transparent. It might be this all. It seemed like there was one more that you could use if you wanted to. But anyways, we're going to just use this mode S. So I'm just going to copy and paste that. And we should be good. Let me make sure we're fine on that. Where are you? Am I looking in the wrong place? No, it was under screen. Set simple screen. Lock, clear screen copy straight. Yeah, mode. And then there's nothing else. So we should be fine on that. So that should be copied to our screen, and then that's it. That's all we need for this function, I'm pretty sure. Just copies it there, and once it finishes the loop, it's done. It's copied it there. So we need to update this draw grid function, or maybe, oh, we haven't even added it yet. So let's add that really fast. And then we're going to use it down here when we init the screen. And we need to init our box as well. So I'm going to do that as well. So box screen equals new screen. I believe that's what we called it, wasn't it? Let's go take a look. Grid box screen, that's what we called it. Grid box screen, like that. Okay, and then we'll be running our function down here. So this is grid box screen. That's the one we're passing through there. And this is grid screen. The tile width will be 8 by 8, and then I'm just going to pass in the screen structure. It maintains the width. It keeps track of the width and height that you passed to it earlier. Oh, which we haven't done yet. I'll show you that. Grid screen height, like that. So we actually do need to allocate both these. So let's do that really quick. Alloc simple screen, which is it wants the depth first, which is 8, and then I think it wants the width and height. In this case, it's just an 8 by 8, and then grid box screen, like that. And then for our grid screen, same thing, it's 8-bit depth, but this is going to be 320 by 320, and it's just the grid screen, like that. Okay. Should be fine. This is 32, 32. Yeah. Okay, and those are getting passed through. It should draw that now, so we should be fine. In fact, we can test this out right now. I just need to comment out this section, all this code basically. Yeah, let's go ahead and comment that out. See what we're missing here. I'm sure there's a syntax error or something somewhere. If I can find the error. Error, conflicting types for grid sprite. Oh, I'm using grid twice. So let's go through, let's rename some things. We'll call this grid scroll, like that. Scroll, and just add scroll to everything so it's unique. Scroll. Because in the test patterns, I do have a grid in one of those, and so I'm duplicating the name and it doesn't like that. And that's fine. We can just add scroll to everything here. And grid screen equals null. I forgot to add that in, so it's good that we're doing this. Scroll. Just gonna copy that, paste, 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 and then paste, paste. Renaming things can be grids, box, screen. Yep, just like that. Okay. See what it's complaining about now. Oh, I need to save all my documents. There we go. Okay, this is where I want to see errors. Grid screen 754, I missed one right there. Probably missed another one. Oh no, I didn't. Error operands. Okay, 754. Don't need a 1. Oh, this is sprite. Sprite. Good, good, good. Error identifier 762. I probably just, yep, messed up. Need a semicolon. Syntax error. Okay. What else is it complaining about? Error, too few arguments to hline. Did I forget to pass the screen? I think I probably did. Oh no, that's fine. H-line, destination, exit. Oh, color. So I assume this is just the ID that it wants. Draw a horizontal line onto the screen. It's looking for an integer. Yeah, I think it's just looking for the 8-bit value for the palette. Let's do that. So we just want it to be the second value, which will be white. So like that. Oh, getting there, I hope. Error. Grid pixel height undeclared. Grid pixel. Oh, I just spelled it wrong. Grid pixel height. And it's line 87. Grid pixel height. Like that. There we go. Just a typo. Okay, let's see if this crashes. Oh, I need to add the function. I haven't added the function to our state machine yet. So we'll do that here really quick. So main and right here. There we go. Okay. Let's go see if we can see a grid. That's what we're looking for now. And we haven't actually attached anything yet. So let's do that really quick. It's definitely working. It's good that it didn't crash. That's a good sign. But we do need to load the graphics. So we've drawn it. Now we go grid scroll sprite. Am I using that somewhere already? Oh yeah, right there. 0 7:30. So I was just checking the time there. We're coming up on 8 o'clock. That's when I'm gonna get off here. So, sprite of screen, and it's looking for an XY position. We'll just go ahead and put this at there, and then I think it's just looking for the screen structure. Scroll screen. Yeah. And those are going to be sharing the same data buffer for its pixel data. So we should see. Oh, we made the sprite. Now we need to attach it. Grid scroll sprite 0 to the display. At layer, let's just go ahead and do the topmost layer. Okay, we should see something. Hopefully it'll be a grid. We have dots. So it is working. We are getting what we are getting something. It's just it's not drawing it correctly for whatever reason. So there's something I don't understand about that horizontal and vertical thing. So what we're going to do is we're just going to draw a line. I may come back some other time and we just give it coordinates, so it's x first point to its second point, and then it just draws it. Excuse me. So let's see if I can be clever with this. It's xy. So its first x point is determined. It's just going to be 0, 0. And then it's going to be drawing straight across to the last pixel. So it's going to stay on, well, on the X, it's going to tile width -1. And it's going to stay on the Y. So there's that one. And I'm just going to copy and paste that. This one, our first point is going to be at the X is going to be at tile width -1, and it's going to, and then it's going to be at Y0, and it's going to be at, tile width -1 to tile height -1. Like that. That should do the trick. There it is. There's our grid. We have our grid. Yay! We have 20 minutes left. Let's see what we can do here in 20 minutes. You know what we could do? Because we're... Wait, no, that's going to double up. Yeah, so this works. This is fine. This is fine. We just need to do our second buffer now, our second sprite, I mean, because we're only doing it to one. So we're doing two sprites, which will be on two different display layers that we'll use to scroll. And so the first one will scroll, and then it will hop down like that, and then hop down like that, hop down like that, and it'll just keep looping forever, and it'll do that on the horizontal as well. We may not finish this today. Because I know my code for that scrolling is set up for something quite different, but it may go really fast here too. I'm not entirely sure. So we're going to do two different display layers. So the second one, yeah, we're going to do our second sprite, which is, yep, that's fine. We're going to set it. It's going to be. Let's have it scrolling horizontally to the left first. And so we want to put the second sprite at 320. Like that. It's going to be on the other side. And it's going to be on layer 14. Yes. Yep. That is correct. Make sure that one's set. Okay, those are both set. Should be good. I'm not going to worry about unloading now. I'll just leave unload sprite graphics data. Unload graphics. I'm just going to leave a note there so I know to come back to it. Okay. Vertical. Nope. So what I'm going to do is I'm just going to bring this down. So we got that. Oh, this is actually, I think this is going to work great for what we're doing. So we don't need these if statements here because those were used to separate the foreground sprites from the background sprites. So we don't have to worry about that anymore. And then this just goes over here. And we just need to change this to 320. Yeah, this is just 320 because that's... In fact, this is making the sprite square actually makes this the code a lot easier. In fact, I could probably simplify this because it is equal on both dimensions. So it's only running this once, and I'm just changing whether it's X or Y. But I'm not going to worry about that right now. And then this is... Let's see here. It's 14. Plus I, because we're only going through two of them. Move horizontal background. Move horizontal. I'm just going to call move horizontal. That's our Y. In fact, this should already be working. Error. Display. Oh, whoops. I did delete a bunch of... Oh, we just changed it. So this is 2. Yeah, and see, I'm already kind of doing this because I abstracted this name so it could be either X or Y. So we may figure that out. We'll see. We'll see how far I get here in the next few minutes. Yeah. So this should loop seamlessly. Oh, it's not. Wonder why it isn't. Position. Oh, that's why. So the first one will be 0, and the second one will be 320. These are our starting positions. Yeah, we're getting there pretty quick, Matt. We should have this maybe not completely tied up today, but we will have most of it tied up. Why in the world? Because what this is doing here, I can show it down here, is it's setting the initial positions. I shouldn't have to do this, but might as well. So this is going to be at pixel 0. It's going to start at pixel 0, and then the second one's going to start at pixel 320. Which, yeah, that's correct. We're good there. They're on different display layers, which is correct as well. And we're scrolling just through 2 of them. And so it starts at 0 or 14 plus 0, so at layer 14, which is right. Let's do this. I think this might be the issue. That shouldn't be a problem, but anyways. And then if, and our vector right now is going to the left, and so that's what this X is. It does a check to see if it's gone, so our first sprite has gone to negative 320, and if it has, pops it back to 320 plus whatever the difference is. Yeah, that's fine. And then if it's going, we're not worried about this right now. It's just this one. So that should be Yeah. Yeah, I think I just had those mixed up. Those needed to be swapped around. Let's give it a try. See what happens. It's going through both of those. Huh. Screens at 320. Outlook simple screen 320 by 320. That's fine. Probably I just missed something here, because this should just be working out of the box. Move horizontal. Going vertical right now, or not going vertical. Scrolling. Yep. If it's less than 320, then set that position again to 320 minus if it shifts a bit faster. This is just to make sure that they line up when they do shift back. So I know this is working because it works in the scroll test that you can see up there right now. It's working just fine. That's why I'm a bit confused here. It's doing 0 and then 1, which is 15. So it is hitting both display layers. It is moving both of them. Here, I'm going to do something really quick. Oh, I'm not drawing the other... oh, no. That's fine. That's fine. Here, I'm going to do something really quick. Oh, no, I can't do that because they're using the same buffer. They're sharing the same buffer. Yeah, why isn't that working? There's really not much other code here. There's just the code for the vertical scroll. There's something I'm missing here. 320 plus 320. Yeah, so it just puts it at 320. That's correct. First sprite is at 0. That's correct. Right there. And then it just starts adjusting that value, and then it... Oh, duh. These need to be set at 0 and 0. It's because we're moving the display layer, not the sprites. And so we have to make sure the sprites are painted at 0, 0 on the display layer, and then we shift the display layer like that. And so, yeah, I think we got it now. This should work. There we go. We got it. It won't be perfectly smooth because we're running it in the emulator here, but okay. And that actually, if we uncomment some other code, in fact, I'm just gonna, I think we're good to go, actually. I might be able to just uncomment the rest of this and it'll work just fine. I do need to check these button presses to see what they do. So for example, we don't need this load graphics anymore because we're not having to reload the graphics. We do need to reset positions. So we just our what is it called? Our display position. Display position 0 equals 0, and the second one equals 320. Equals 320. And the other thing I'm going to do here is we're going to set our acceleration. We're going to set it to -1, so that resets when we switch between vertical and horizontal. That's fine. The speed stuff should all be working just fine. We just need to update our Y position here, which actually I don't think we need to do, because we abstracted the display position because because it's the same set of sprites and they're square, so they're 320 by 320 each one. So I don't think we need to do another check for the Y position. We just need to switch the vector between X or Y. Oh, this is the difference right here. That's fine, because, excuse me, we can just do an if statement up here. So we can delete this, and then we do if let me think. In fact, we can run this all the time now on this one, unless it's paused. If vertical equals 0, we do the x-axis, and if it's not, we do the y-axis. So in the way we're doing that, so these last two values in this move display layer are x and y, and so we're moving x on this one, otherwise we're moving y. The other thing I want to do, oh, I've already set it here, so we're fine. Yeah, I think that's it, and we'll have this in the bag. Pretty sure. I'm gonna add a break there. Okay. Let's see what it does. Let's see if I'm smart or not. Okay, so speed should be working. You won't be able to see that too well, but it is working. We should be able to pause. We should be able to switch the vector. Let's make sure that that's working. Looks like that's working. Or switch, yeah, we're switching the horizontal vector, and then if we hit K, yeah, it just sets that. And it looks like we are not lined up correctly. So I just need to make sure that we set what we'll do is right here. Oh, whoops. This might be our problem. I'm going to run this anyways. This may be redundant, but I'm going to do it anyways, just in case. And we just set all the displays back to 0. So we want to do layer 14 and layer 15 we set back to 0, like that. And so we're just resetting it each time. Oh, whoops, I screwed up on that too. This is 0. We're just resetting it as if we're coming back into it again, except now the vector it'll be going horizontal rather than vertical. So, video grid scroll test. Huh. Why isn't it scrolling? Did I accidentally? No, it's switching it. Oh, I was pausing it. I wasn't. There we go. There we are. Like that, like that, like that. So we can switch between those. We can speed that up to basically a useless speed. We may adjust that in the future. But anyways, there it is. And we can switch the vector on both of those like that. Cool. We got it. That's done. The last thing we need to do is properly unload everything. This is kind of boring stuff. Thanks, Matt. Yay! We got it. I'm glad when these programming streams kind of go to plan, even though I don't get quite as far as I would like to. I always feel like I can get a lot more done programming than I actually can. I don't know if I'm just slow or if that's just how coding is. I honestly don't know. It feels good to get something done, though, regardless if I'm a little bit slow in the head or not. Okay, so we need to make our sprites invisible first. So grid, scroll, sprites. We technically don't need to do this, but I like doing it just in case. I just think it helps avoid seeing artifacting on screen as it's unloading stuff. The reason why I think we might not need to do it anymore, this is how I used to do it before I knew about hiding and showing display layers, because when we hide those layers, I don't think it will show anything until we show them again. So, but I do this anyways just for old time's sake, I guess. We make them invisible. Do that to number 2 as well. And then we detach them. Detach sprite. I'm just going to copy this. Oh, really? Copy. There we go. Detach. Do that to our second one as well. One, and I screwed up on this. There we go. And then we can free those. FRE. FRE. And I'm actually going to swap these around because it may not like that I'm detaching the first one before the second one, or freeing them at least, and so should be fine. And I'm going to set those to null while we're thinking about it as well. So grid, scroll, sprite, 0 equals null. Paste, and 1 like that. Okay. Yeah, it should be fine. I could probably just type in without the array identifier, but I think we're okay. Just in case, we'll do it that way. Okay, now we need to disallocate our 2 screens. And this is always a little bit trickier. So free, we have to do grid, scroll, screen. You have to do the data portion first, and then the structure itself, like that. And we do that for our box as well. Free, not gree, free, grid, box, no, scroll, box screen, data, like that. I think that's all we need to do. Let's test it. Oh, let me make sure that when we exit vertical is 0. I don't think that matters anymore. Because it's only going to run this if it's null. So yeah, I don't think that matters anymore. So we can get rid of this. We're just going to run it through load graphics again, exit, it hits this exit, unloads everything, and then breaks out of our while loop and leaves the function. So we should be good to go. Grid, scroll, screen. So if we hit option and leave, Looks like that's loading just fine. I just do it a few times to see if it crashes, because it should crash eventually because we're allocating memory. And if we don't disallocate that memory correctly, it will build up in memory and eventually crash the program. So if I knew the debugger a little bit better in Virtual Jaguar, I could probably use that to check for this, but looks like we're fine. Yeah, so there it is. Let's test it on real hardware here really quick before we leave, and it's exactly 8 o'clock, which is great to see. Where are you? There you are. Let's go over to Jaguar Large. See this on real hardware. See if it crashes anything. Good scroll. There it is. We can speed that up so it's useless. Oh, so looks like we do need to adjust. You'll see that there's a gap down at the bottom. I wonder, oh, that's fine. Let's see here. Yeah, we do. So we do need, let's see if we can fix that here really quick. Is it scrolling still? Yeah. I can pause. Here, I'm just going to do these other tests really quick. And yeah, just like that. Okay, so we're good to go. So I just need to get rid of that gap. So let's go back over to the code. So in our draw grid function, what we need to do is just overlap. Let's see here. No, we just need to draw down an extra pixel. Like that. In fact, this just needs to be width as well. That should do it. Let me check it in Virtual Jaguar first, because it's a little bit faster to check it there. Okay, I think we got it now. Push it out to hardware again. Video tests and grid scroll. Look at that, we still have a gap. Why do we have a gap? Did it actually, did I save? Yep, I saved. I'm curious, was it showing up as a gap in the emulator? Yeah, there's no gap in the emulator. I am not sure what's going on. Let's do this. Let's change the mode that we're copying the box into S and D. I think that's what it is. S and D. I think that's what it is. Let's go double check here really quick. S and source and destination. It's just sad. It's so sad when we have the source and the destination. And it's bizarre that it's oh, I should have changed that. I want to do the like that. Let's see what it looks like here before I reset this again. Oh, it's not showing anything anymore. So that's definitely not the mode I want. Oh, it's an AND operation. So we want actually source or destination. Where are you? It's probably just SOR. Source, oh no, it's S or D. S or, there we go. Because what I'm hoping is that we're actually just copying, we're erasing some pixels when we get to another row. So with S or D, it will keep the pixels and just add them on top, basically. No, we still have a gap. I do not know what that gap is, and it's strange that it's not showing up in the emulator. Yeah, it's just not. Let's see here, box. We're starting at width. Here, let me just get rid of these really quick. Let's see what this looks like. Because tile width. Yeah, and that makes sense because I think we're going outside the boundaries. So this definitely needs to be -1. And this needs to be -1. This one like that. That puts it in the boundaries, and then I don't understand why the height isn't working. Did I not? Where are you? Here. In fact, we can do this here as well. Width and height, like so. Yeah, 8 by 8. So we should be overlapping technically on our pixels, but I kind of want to see it doubled up first. But that could be causing the problem as well. Let's do this. Let's draw the whole box. So this is the tops, this is the right side. Let's do the bottom and the left. So the bottom would be 0, and then tile, let's see here. Yeah, tile height -1. And then it draws to tile. Oh, wait. Did I mess this up? No. That's fine. It's drawing 8 pixels over. And I just don't know. Let's see here. I think I do have something wrong here. Pixels 0, 0, 0, and then this needs to be -1. Pretty sure that needs to be -1, and it's oh, let's see here. yeah, this is correct. We're not going down any pixels. And then we're going to top right pixel right there, and we're drawing to, yeah, this should be -1 as well. Pretty sure that's -1. Because these are coordinates at the end of the day. So I'm going to manually input these. So we're drawing from pixel 0 to 0 to pixel 7, 0. So that's 0, 1, 2, 3, 4, 5, 6, 7. For the 8th pixel, it's going to be the 7th. It's ID 7. And then this one is the furthest right pixel, which is 7. And we're still at the Y, to the furthest right pixel at the furthest down pixel, which is the 7th one. That's what our values should be for an 8 by 8. And we shouldn't have a gap down at the bottom with that. I'm just wondering what's going on. Skunk reset. Or make reset. there it is. That was weird. Wonder why it didn't work that time. There we go. Grid scroll. Yeah, there should not be a gap. Because if I tell it to go 1 extra pixel down, like if it was 1 to 8 rather than 0 to 8, which doesn't make any sense to me, but maybe that is how it's working. I don't know. I assume he's using, yeah, there should not be a gap there. And technically we're drawing outside of the buffer, which he may have some checks to make sure that that doesn't happen. Oh, wait a second. He says something. Let's see here. Screen copy, put pixel, write a pixel. There's something, he has a warning here. Draw a line onto the screen from point x1, y1 to point x2, y2. Even if hardware clipping is enabled, it is recommended that the x1 and y2 are coordinates inside the screen. Rotate a screen. I'm not sure. This is a little... You know what we could do? Let me back out on all this. Yeah, I'm pretty sure this is all correct. This is all good right here. Just so we can make sure we're not drawing outside the screen coordinates, is we can pass it, we can actually make this 16 by 16 like this, and define a tile height of 8 by 8 like that. Let's just make sure that's working in the emulator. Okay, it's working there. Seems to be working fine. Because maybe we're being too precise with our measurements, and for some reason the actual hardware doesn't like that. It sounds kind of like a lame reason, but because I know yeah, it's working now. I've painted 8 by 8 sprites before, so I'm not sure why it's having an issue. Box Y, tile width, tile height. Yeah, there's something about drawing those lines using this line function. It isn't hitting that last pixel on the vertical for some reason. So I don't know if that's a bug in the removers library or there's a limitation I'm not aware of. But anyways, we got it. That is working. So we can pause that, switch the vector, speed it up. Like that, which isn't too useful. Switch the vector. Could have sworn we had a better. Yeah, like that. Anyways, okay. I think that's where we're going to stop for today. I'm 15 minutes over, which isn't bad. I've done a lot worse before, right? Yeah, thanks for watching. Tomorrow we'll just keep trudging forward. We have some vertical and horizontal line tests that we have to do. And what else? What else do we have? We have, yeah, we have stuff to do. Let me be more specific. Yeah, so we have our stripe test, our checkerboard test, which those are pretty much already done. LED zone test. Not sure what that one is. I need to check that. Alternate between 240p and 480i. This may not be applicable for what we're doing on the Jag. And then we're done. And then we just have our lag tests and our So I may need to do a little bit of research this evening before we do that, because I think we'll probably end up finishing these stripes and checkerboard tests, and maybe even this LED zone test. I need to go see what that is, and we may be jumping into these, so I'll need to brush up on those. But yeah, thanks for watching, Matt Smith. Anybody else who was watching, thanks for watching. Have a great day, and we'll see you tomorrow. Bye.